All right. A lot of this is stuff that, well, first of all, hopefully you have tried these problems on your own and you've checked them with the key. Now, you really only need to watch this if you got something wrong on your trial problems, okay? You can still watch it to help give you a little bit of detail and explanation. If you weren't 100% sure of why your answer is right, you have the right answer, but you kind of just guessed, then watch this video, obviously. And so first thing you want to make sure you do is as you're reading this, you want to see it shows you that your graph has your height is h in feet of a small rocket after t seconds from being launched. So our path is given here in this graph. Here's our rocket, it's going up, it's going up, it's going up, and now it's coming down, it's coming down, it's coming down. The equation is given here as h of t equals negative 16 t squared plus 128 t. So for most of these questions, you can just use the graph to help you answer it, okay? There are a couple that stated to use the equation, and I will show you how to use the equation, and I'm also going to show you how to use Desmos, okay? So this is your time down here, and this is your height on the side. I want to point out, first of all, that there are not arrows on the end of this, and there shouldn't be, because your time can't be negative, so you can't have negative x values, and your height can't be negative. Your rocket is going to start here, and it's going to go and stop at the ground. Now, depending on what type of rocket we're talking about, yes, I understand that if it's a big enough and has enough power, whatever, it could put a hole in the ground. Let's say it's a small rocket, just a little model rocket that we're throwing up into, launching into the air. When it comes down, it's just going to hit the ground and it's going to stop. Okay? So for the most part, all of our problems we're going to talk about starting here at the ground, or maybe it starts somewhere else. Maybe we launched a rocket off the top of a hill or something, or we were in a tree or something, so it's not on the ground. You launch your rocket, it goes up in the air, and then it's going to stop whenever it reaches the ground. So the first question asks you, how long is the rocket in the air? Well, how long is it in the air? So in the air, all this is up in the air because we're feet into the air. It shows you that our height, we're still in the air, but we're coming back down, but we're still in the air, and we stop being in the air right here. How long did that take? Well, where did we stop? We stopped after 8 seconds. So we're in the air for 8 seconds. What is the greatest height? So greatest, biggest, height. So if you just look at your graph and find, well, where's the greatest? Up here, we go ahead and look at this value. We see that our greatest height, it's one line above 250. And if we look at our scale, each one of these lines, 1, 2, 3, 4, 5, means we're counting by 10. So that's why your height should be 260. And 260 what? Can't just leave it as 260. It is 260 feet. When does the rocket reach its greatest height? So when does that happen? So it reaches 260. If you follow this line down to look at your time, you see that your time is 4 seconds. So it reaches its height, greatest height, after 4 seconds. Next question is, how high is the rocket after 1 second? So if we look at our 1 second, then we come up and we look at our graph. Then we come over and look at our y value. We see that it is at 100 feet. After 1 second, it is 100 feet in the air. Next one says after 2 seconds, we're going to do 2 parts. First, we're going to figure out how high is the rocket. It does say to use the equation, not to use the graph. The reason for that, if I go 2, just like we did for 1, we've got this little dot here, but you notice how that dot is not quite on the graph? That means if we were to use the graph, it would only be an estimate and it would not be accurate. So we're going to use the equation. So what we're going to do is we're going to take our equation, which said h of t equals negative 16 t squared plus 128 t. So here's our equation. We want to find the height after 2 seconds, and t is our time. So that means we're going to plug time, which is t, we want 2 seconds. So we're going to take our h of 2, and we're going to do negative 16 times 2 squared plus 128 times 2. So this is how you use your equation. Negative 16 times 2 squared plus 128 times 2, which then you can go to Desmos, which let me open that up real quick. Didn't have that ready. My bad. We're going to do negative 16 times 2 squared plus 128 times 2, which is how we got 192 feet. So if you would have approximated, if it said what's the approximation, you could use this point, but we wanted the equation. Now, if it didn't tell you that you had to show work, it doesn't say anything about using the equation or something like that. If it just asked you how high is it after 2 seconds, then you can use this function. I'm going to type that into Desmos exactly how it's written. H of t equals negative 16 t squared plus 128t. In the line below, I want to find after 2 seconds. I'm going to type h of 2, and it gives me my answer. That is only going to happen if you have h of t and then fill in your function, okay? But if it says to use the equation, it wants you to show the work like this, okay? The next part here for the same question after 2 seconds, it's now asking you if the rocket is going up or if it's going down. So if we look at 2 seconds and we continue the path to 3 seconds, your rocket is going up. After 6 seconds, how high is the rocket? Once again, it says use the equation. So once again, now we want to come back here. We want this time though for our time, our t, to be 6 seconds. So we're going to use the same equation, except this time we're going to plug in 6 in for both of our t's. So we want to find h of 6, which is negative 16 times 6 squared plus 128 times 6. And I can go back to, oh, that's not what you need. That's my own work. Come back here, we do negative 16 times 6 squared plus 128 times 6, get 192. If it didn't say we need to use the equation, we can just change this h of 2 to be h of 6 and get 192. So after 6 seconds, it is also at 192 feet. Now it asks you, is the rocket going up or is it going down at 6 seconds? So at 6 seconds, if we look at how from 5 to 6 to 7, we see that the rocket is going down. It's traveling towards the ground now. Part 7 says, how long does it take the rocket to go 240 feet in the air? As long as it doesn't say anything about using the equation, we can just use our graph. So we're going to go to 240 feet in the air. So if here's 250, 240 would be the line underneath. We come across and we see this dot right here. And then when we come down, we see that it is at 3. So how long does it take the rocket to get to 240 feet in the air? It's 3 seconds. We can verify that if we come back here and make this h of 3, that yes, it is in fact 240 feet. And then what height did the rocket take off from? Well, look at when it took off. That time is 0. We see that it is at 0 feet, or it's on the ground. Okay, so a lot of these questions should be relatively easy. A lot of them are, honestly, do a little common sense. Read the problem, make sure you know where it is you're looking at. If it asks you the greatest height or the maximum height or something about that, you're looking at the highest point. If it asks you about when it starts or when it takes off from or in the beginning, you're looking at this very beginning point. If it asks you something about how long is it in the air, we'll look to see how long until it's no longer in the air. If it gives you a certain time and wants you to find a height, well, that depends on how the question is worded. If it just says after 1 second, find the height, you can look at your 1 second at your graph. If it says use the equation, then plug that number into the equation like we did here. If, once again, it doesn't tell you that you have to use the equation, you can either use the graph or you can come back in here and type h of whatever. As long as you have your function in Desmos, you can type h of whatever number it is you're looking for. Okay? Hopefully this is pretty helpful if those of you who did miss any questions on the initial worksheet. If you have any more questions as you start doing your own that are now going to be worth credit, so this first one was not for any grade, it was just for practice to get you started in thinking. If you have any questions along the way on the next part, please make sure you do reach out to me and I'll help you as best as I can.